question 5d. So it says use your answer from C to find the area of the triangle PQR. Okay, so let's have a look. So we've got our triangle here, PQR, and it wants us to use this answer that we've got from our previous question. So we need to take into account what's going on here with that line and understand. So in fact, just before we do that, let's think area of a triangle. What's the formula for area of a triangle? Half of the base times the height. Yes, so that's what we've got to do. It's what we've got to get to. How are we going to get there? Well, let's look at this triangle, and I'm just going to twist this triangle around a little bit so it's a bit located this way. So what I can see here is that I've got this line here, PR, and I could call that line there my base. Now the reason I'm going to want to do that is because remember this line here is perpendicular. So this is the height of our triangle. So that's our height. So we've got the equation for that. We don't yet have the equation for PR, but we can find that. And once we've got the equation for that PR, we're going to be able to find this intersection point here. And I need to know that intersection point. I need to know it because I need to find the distance of that line there. So I need to find the distance from Q to this coordinate point there. I need to know how tall, what that height actually is. So I need to find where that line intersects with this line here. So that's what I need to do first of all, is I need to find the equation of this line so I can find the intersection point, find the distance there, find the distance there, and then I can substitute that in and find the area. Okay, so that's what we want to be able to do. So let's take a look. So we've got the equation there from part C of that line, y equals a half x plus 5. We know about perpendicular lines. Let's think perpendicular lines. What do you know? Well, if it's perpendicular, then we know the gradient of one times the gradient of the other is equal to -1. Or equally, we could say that one of the gradients is the negative reciprocal of the other. So if I know that this gradient here is a half, then the negative reciprocal of a half must be -2. So I know the gradient of the line PR is equal to -2. I think we've actually calculated that before. So we've got our gradient for our line PR. Now we need to know what the equation is. So we've got our general formula we can use, y minus y1 equals m bracket x minus x1. So what coordinate point are we going to use for x1 and y1? We could either use P or we could use R. I'm going to use P simply because it's there at the top, but equally you could use R. So y take away y1, which is our value of 6, equals m, which is our gradient of -2, bracket x take away x1, which is -3. So now we're going to do a bit of simplifying. Y minus 6 equals -2. Now take away -3, that becomes x plus 3. Now expanding out that side of the bracket, so -2 times x is -2x. -2 times plus 3 becomes -6. And now I'm going to take this -6 to the other side to get it in that form y equals mx plus c. So y is equal to -2x take away 6 plus 6. Those two will cancel out, positive 6, -6. That leaves me with the equation y equals -2x. So this is the equation for PR. Okay, that's what we've just found, is we found the equation of the line PR. Okay, now what do we need to do? Well, remember we're trying to find out, we've got that equation of the line PR, we've got the equation of this perpendicular line, we're trying to find where that intersection point is there. So we're going to write down those two equations, y equals -2x and y equals, from part C, a half x plus 5. And I want to find where these two lines intersect. Okay, so if y is equal to -2x and y is also equal to a half x plus 5, then -2x must be equal to a half x plus 5. Okay, x is on one side, numbers on the other. So I'm going to take this half x across the equal sign, so -2x, take away a half x is equal to 5. Negative 2x minus a half x, that's going to give me negative 2 1/2 x. Equally, I can write that as a mixed fraction, and that would give me improper fraction, negative 5 over 2 x equals 5. Opposite of dividing by 2 is to multiply by 2, so minus 5x equals 5 times 2. So minus 5x equals 10. And now I want to get rid of the minus 5, so the opposite of multiplying by negative 5 is dividing. So divide both sides by negative 5. X is equal to negative 2. So I found the x coordinate of where these two lines intersect. Now I need to find the y coordinate. So I'm going to substitute x equals negative 2 and 2, and I'm just going to use y equals negative 2x because I like that rather than using the half, but you could use the other equation. So if x is equal to negative 2, then y is equal to negative 2 times negative 2, which means y is equal to 4. So the point of intersection for the line PR and the perpendicular line is when x is equal to 2 and y is equal to 4. Okay, so what did I need to do that again for? Well, let's go back. Let's add that information on here. So we have found that this intersection point here is when x is equal to, negative 2 there. I should do it negative 2 and 4. Okay. Don't worry about the exactness of the diagram. It's roughly in the right place. So I've found that coordinate. What was I trying to do again? Oh, that's right. I was trying to find the area of the triangle. So I've got my formula, area equals a half of base times height. So I need to find out how long the base is. So my base of my triangle is that distance P to R. So I need to go from point P to point R and find the distance of that side there. Then I need to find the distance from here to point Q. And once I know those two distances, I can substitute the base and the height into my formula. So that is my next job, is I need to find some distances. Okay, so let's find the distance of PR. So we've got our formula here, y2 minus y1 squared plus x2 minus x1 squared. And we're doing P and R, so what were the coordinates of P and R again? Let me just go back there. So I'll just write this down here. P is negative 3, 6, and R is 1, negative 2. Okay, so I've just written them down separately here to remind me. So we're going to do this. I'm going to do this one as x1, y1, x2, y2. So my y2 value is negative 2. Take away y1, which is 6, squared. X2 is 1. Take away x1, negative 3 squared, and I want the square root of all that. So negative 2 take away 6 is negative 8 squared, plus 1 take away negative 3, so that becomes 1 plus 3, which is 4, and I want the square root of that. So when I go and do that, negative 8 times negative 8 is 64. 64 plus 4 times 4, which is 16, gives me the square root of 80, which I can turn into decimal, which is 8.944 to 3 decimal places. Okay, so I've found the distance of PR. So I'm just going to draw my triangle here. Remember, PR, and I've just rotated it round. So I found the length of this side is 8.944. Now I need to find that height, okay? Because there's our perpendicular height. So that's what I'm looking for next. I know the coordinate point here, and I know the coordinate point at point Q, and I'm going to use those two coordinates to find the distance. So, well, let's have a think. So we know point Q. I'm just going to write the coordinates of point Q here. The coordinates of point Q are, let me go back back to there, is at 4, 7, and the coordinates where they meet, and I'm just going to call that the perpendicular one, is at -2, 4. Okay, with that I want to now go and find the distance. So I'm going to call it x1, y1, x2, y2. So my distance of q in the perpendicular is our square root of y2 minus y1 squared plus x2 minus x1 all squared. Okay, y2 is 4, take away y1, 7 squared, plus x2 is -2, take away x1 is 4 squared, and I want the square root of all of that. 4 take away 7 is -3, -2 take away 4 is -6, square root of -3 squared plus -2 squared is going to give me the square root of 45, which is 6.708 to 3dp. Okay, so now I've gone and found that distance. So I have gone and found, if I can add that to my diagram here, I've gone and found the distance from Q to there is a distance of 6.708. Now I can combine that together to find the area of the triangle. So that's my last piece, is answering that question. So the area of the triangle is half of the base times the height. So it's half of, the base is 8.944, the height is 6.708, and when I type that into my calculator, and you should get an answer of 30. And the reason, how I know that is if I do this more accurately, if I actually type in a half times the square root of 80 times the square root of 45, that is more accurate, and that's going to give me the exact answer of 30. If I use rounded answers, you're going to get 29.988 or something close to that. So it's not going to be exactly 30, and that's just the rounding error from the calculations. So to be really accurate, which as a mathematician we do need to be accurate, let's go back and actually put those, that's why back in the original ones I wrote it down as a square root of 80 so that I could use that as an accurate answer later. So there, the area is 30 units squared, and that's the area of our triangle.